Okay, we are going to talk about properties of logarithms. First thing we're going to talk about is the change of base formula. Second thing we're going to talk about are the properties in which we could expand and condense logarithms. Okay, and then I'll give you some problems to do within your pods. Okay, so the first thing we need to talk about is the change of base formula. Your calculator is programmed in base 10. Well, if we have a logarithm that is not in base 10, we need to understand how to change it. Okay, so I'll let you write down this formula and then we'll go from there. This change of base formula works with any base. Okay, so if you knew how to calculate in base 7, you could use base 7. Okay, if you knew how to calculate, or if you want to use natural log, you could use base E. Okay, just whatever it is. Okay, the number that's inside the base is in the top logarithm. The number that is the base is in the bottom logarithm. Okay, you wouldn't necessarily need to write these down, but these are the two versions that we're probably going to use. This one because it's base 10 and that's what our calculator is. This one is base E. We also have this button in our calculator. Now, this is a very simple process, how to take a logarithm and evaluate it in our calculator. Please practice this, because if you don't practice it, you are not going to remember it for Friday. So on the next slide, there's going to be two logarithms that we're going to need to evaluate with our calculator. Okay. So we'll talk about using the change of base formula, and then I'll help you find those buttons on your calculator. All right. Okay, so go ahead and write down log base 4 of 25. This is asking us 4 to what power is 25. Without actually putting it in our calculator, we have an idea of approximately where it should be. Okay? What is 4 squared? 16. What is 4 cubed? 64. So since 25 is in between 16 and 64, we know that log base 4 of 25 should be between 2 and 3. Okay? So in your calculator, what you would need to do, let's see, we would need to type in, your log button is right here, log of 25 divided by log of 4. And look at that, it's between 2 and 3. Okay. We could also use the natural log button, the natural log of 25 divided by the natural log of 4, and that would give us the same output. Okay? You can use either logarithm, it doesn't matter which one. Okay? So my next example is log base 2 of 12. Let's first determine where this is going to fall. Log base 2 of 12. between which two numbers is this going to be? Two to the what power is 12? 3 and 4, who said that? Okay, why 3 and 4? 8. Okay, 12 is between 8 and 16. 2 cubed is 8, 2 to the 4th is 16. So this better be between 3 and 4. Go ahead and find it for me. That's a good question. What do I do on the quiz? I think it's 3 decimal places. Yeah, let's go 3 decimal places. So Addie, what would our 3 decimal places be? 3.585. Okay, sounds good. All right, so you talked about properties of logarithms last year. Remember, logarithms are exponents, so we have rules of exponents, right? When we multiply with same bases, when we divide with same bases, when we take a power to a power. That is how we get these logarithmic properties. So let's first talk about the product property of a logarithm. Okay. Prior to that, you learned about properties of exponents. If you have, don't write this down, a product where you have the same bases, what do you do with your exponents? We add them, okay? So how that translates to logarithms is if there is multiplication inside of your logarithm, you can add 2 separate logarithms together. Because we're adding our exponents, we're adding our logarithms. Oh, I wouldn't write this down if I were you, but please understand that log base e is going to have the same property, okay? It's redundant. I wouldn't write it down, but you are going to see it with both log base a, log base e, which is the natural log. All right, the quotient property. Let's talk about when we are dividing with exponents. What do we do with the exponents? We subtract them. So, if we have division inside of our logarithm, then we are going to subtract our logarithms. Our exponents get subtracted, so our logarithms, which are exponents, get subtracted. Same thing happens with natural law. Okay, I wouldn't write it down. Okay. Our last property deals with powers. Okay. When we, don't start writing down yet. When we take a power to a power, what do we do with those? We multiply. So if we have a power inside of our logarithm, we can take that power and we can multiply it out in front. Okay, that power inside of our logarithm can multiply out in front. Okay, so we're going to do a couple examples here. Go and write down these two. We're going to expand both of these. So here's a 1 logarithm with a bunch of stuff going on inside. Okay. When I ask you to expand a logarithm, I'm asking you to stretch it out as much as you can. Okay. Write it as a sum or difference of logarithms. Okay. To where there's only one thing inside a logarithm at a time. What one? Okay. So, one step at a time, what's happening with these terms inside of our logarithm? They're being multiplied. So we can write log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. But this would not be a full credit answer. Why? That power right there. That power needs to be taken out. So we would need to write log base 4 of 5 plus this power gets multiplied in front. 3 log base 4 of x plus log base 4 of y. Is it coming back? Yes. We couldn't without a calculator, so I want you to leave it. If it were log base 4 of 4, then we could simplify that down to 1. But you are fine leaving it like this. Okay. That is a good point, though. If you can simplify it, like log base 4 of 4, I would want you to do that. Okay? Over here, this square root. How could we write a square root? It is the 1/2 power. So I want you to think of this as the natural log of 3x minus 5 to the 1/2 power over 7. Now we can apply our properties because we have a power instead of the square root. Okay? If you see any sort of radical, you need to rewrite it as a power. So now we can say, okay, there's division. So I can take the natural log of 3x minus 5 to the 1/2 power and subtract the natural log of 7. And this has a 1/2 power, which means that power better get multiplied out in front. There is nothing we can do with the 3x minus 5. We do not have a rule for addition and subtraction inside of our logarithm. It's stuck there. Okay, there's nothing we can do. Slowly but surely, our cobwebs are getting out of there. We're remembering this stuff. All right, go ahead and write this one down, this first one right here. Okay. Now, I've been taking these one step at a time. If you can do these in one step, I don't have a problem with that. However, if we do it one step at a time, we take out some of the room for error. Okay. So with this first one, this 2 out in front, well, I guess I should also say, we're going backwards now. We're condensing. When I ask you to condense, that means write it as one logarithm. So now we're going to piece it together almost backwards from what we did in the previous slide. So the first thing I would do is I would move that 2 to be a power. And then we can recognize, all right, we have subtraction, which means inside of our one logarithm, we are going to divide. Do not FOIL that out. Do not try to do anything. Just leave it. Okay, leave it as x plus 2 the quantity squared. That's all I need. Okay. And then go ahead and write down that last example. What's the first thing we should take care of in that second example? Well, this power is like to the whole thing, right? So I would almost do the parentheses first so we know where to put the power, okay? So inside, we could write this as x times x plus 1. Whether you want to multiply that out or not, you don't need to, okay? And then you could go ahead and take the x times x plus 1 and give it the 1/3 power. If you want, you could write it as log base 2 of the cubed root of x times x plus 1. I would be fine with either one. I would be fine with either one. All right, so for the remaining 15 minutes of, 12 minutes of class, I have some problems I'd like you to work through. So as a pod, I've given you a blue card. As a pod, you are going to come up with an answer. One member of your group will bring it up to me with the card. I'll say yes or no. If it's right, I'll give you the next card. And we'll just get through as many as we can until the bell rings. Okay? Let's go. Please switch who comes up to check.